Good evening, everyone. This is Tobias, and I wanted to give you guys another video on rendering instance objects onto particles in Redshift and Houdini 18. This is going to be a part 2 to the earlier video that I did. I will probably link that in the description for you. In this video, I wanted to address something that might be a little bit more complicated, which is trying to get randomized objects onto our particles. Right, and how we can do that and get them to render in Redshift. So let's take this a little step further. Alright, so in our previous video we talked about setting up this little situation where we have, let me just spread this out a little bit, sorry. We have a grid that's emitting particles through this popnet, and we have a couple of source objects that we're sourcing through a switch. Right, just to give us the option of being able to select different objects for the entire particle system based on either files from disk or test geometry or something like that. What if we wanted to do something a little bit more creative than that, and say we had a small library of objects or a series of objects that we wanted to randomize in the particle system, as opposed to just selecting one or the other and being stuck with that. So let's just go ahead and explore that option. First, we obviously need to create an object library, and this is the part where we're going to start to need to organize things a little bit more. And this video might be a little bit longer than the last one, but I think it's important to make sure that we cover all the bases pretty thoroughly here. So in the last video we had a sphere here, but I changed it to a platonic for this example. Let's just go ahead and just start thinking about organization. So what we're going to do is create a little bit of sort of a library, if you will. And we're just going to start calling this, this is our object 1. We'll do another null here, and this is going to be our object 2. And for the sake of good measure, let's just add something else here. Let's just add another platonic. This could be another file from disk if you wanted it to be. And then we'll do another null. So essentially, like I said, this could be anything that you want it to be, and you could just go on forever like this. But for the sake of this example, we're just going to keep it like this, and we can go ahead and use our switch still. So that if we wanted to, switch from having uniform objects in our particle sim, we could totally do that. But for this goal, we're going to try to randomize all of these objects into our simulation, right? So that the hint here is that we created these little nulls here so that we can point to them. Alright, so I'm going to show you how we're going to do that here. We're going to use the same pop network that we had before, but this time we're going to incorporate the idea of pop streams in Houdini. And what streams are like little pathways that diverge from how the particle stream is processed, which allow you to give a different set of instructions for the particles that are coming out of your system. So those instructions can vary from changing the color of certain particles, changing dynamics, influences like wind and turbulence and all that kind of stuff. I mean, really the possibilities are endless, but for our case we're going to use that idea, that functionality, to randomize the objects. So you'll see here that we have one stream that goes into a merge and then comes out in our output. But let's start adding a pop stream to sort of branch this out. Okay, and this is our source, so we're going to plug in our source, and in our pop stream we need to identify what particles we're going to operate on, right? Now ideally we want to operate, say, on a random selection, right? We're grouping particles and we're going to do a random selection of those. Now your inclination might be to say, well, let's just go to random and enable that and just add the stream, whatever's going to happen here, and disable this here. That's part way there, but we need to specify a group. We need to make a group selection of our incoming particle. Now the important thing that we need to do in this is, in our source input, we have to go to our attributes and make sure that we have this add ID attributes turned on, so that every single particle that's generated has a unique ID. Okay, and that will allow us to grab that ID and then do stuff with it. So here in this particle stream, if we check on the source group, we can create a group of particle IDs. Now the best way to do that, to really make it truly random, is to use the random expression and to change that selection throughout the simulation, so every frame. So the easiest way to do that is just use the system variable, global variable $f for the frame number, and we're just simply going to multiply that by a random at ID. Now the ID is the ID of the particle. Okay, so now we have this grouping here, and we're going to enable the adding to the stream at a 50% chance with a 0 seed of something that's going to happen after this node. Now you're probably guessing the first thing that we're going to do is add a pop instance, right? Because we're going to change the object that is being used. So in our first instance, we originally, in the first video, if you remember, we just used the entire group. We used that switch to switch between different objects. Well, in this case, we're going to change that. We're going to actually go to our object selections directly, right? So this instance is using that object, the very first one. This instance is going to use, say, our second object. Okay? And we can do, I'm going to take this pop wind off here for a second just to sort of clean up the view here. And the idea is that we just merge this in with our result. And as you can see, instantly, we have a mixture of these two different objects. And you just keep going down that logic, right? So pop stream again. And we're going to do a same selection, right? So $F, because this gets us the frame. I'm going to multiply that by a random ID of the points, right? Or the particle, right? And we're going to not use this rule, we use a random rule to enable the chance of it getting added to the stream is 50%. But in order to make sure that we get a different ID, we need to change the seed to anything other than what's in the other streams, or the other, yes, pop streams, right? And then again, we're just going to do another instance, and we're going to select our next object, right? Wire that in, wire that into our merge, and here we go. Now we have 3 different objects being emitted from our emitter. Now the cool thing that we can do with Redshift, is rather than assigning different materials to all of these different instances, we can just use one material. But say we wanted to make sure that all these had different colors on them, we could simply add the pop color node, because this still works on particles, of course, because these are still particle IDs, right? So we'll just do another one, right, and then another one, and we'll just go in and make sure that we're changing the colors. I'm going to grab a color here, let's say red. We'll change this one to green, and we'll change this one to blue. Okay, so now each one of these streams has a different color assigned to it. It's a color attribute, right? And we're getting our output. And all we have to do now is go to our material. Now I've already done this, so you may be able to tell because you can see it here. But if you go into our material, the one that we created earlier, if you remember, we just had one material that was assigned to the particle. But in Redshift, we can grab an attribute from points. And the way that we do that, I'm just going to go ahead and delete this for you. We're just going to do attrib, right? And you're going to look for this Redshift point attribute. And we're going to tell it the attribute that we're looking for is CD, because color in Houdini is CD. And we created a different color for each one of those points. And we can use that in our diffuse color. Now this single material that's in here, that's assigned to our output particles, is reading the color attribute per point, so that we're getting all of the different colors. Okay? And now, if we bring up our render preview, now this isn't going to work in my case because I have some weird buggy thing going on in my system where sometimes, depending on if I close the original window, it doesn't rebuild itself properly. But on your end, when you click that render view, you'll get the preview of this, as you see, with all your different objects in there. Okay, and